Ladies and gentlemen, in the world of human performance, few case studies are as compelling as the relentless drive of David Goggins. What's fascinating is not merely that he didn't sleep. It's what happens when an individual conditions their neurobiology to override the natural cues of fatigue. When Goggins pushes through sleepless nights, he's not just ignoring exhaustion. He's activating deep reserves of mental and physiological adaptation. The human brain has multiple systems that regulate arousal and alertness: norepinephrine, dopamine, cortisol, rhythms. Under extreme stress, these systems can override the need for sleep temporarily, facilitating hyperfocus, heightened perception, and extreme endurance. But this is not without cost. Sleep is essential for memory consolidation, metabolic regulation, and emotional stability. What Goggins demonstrates is that the mind, when deliberately trained, can suppress the dominant biological urges through intense prefrontal activation and sheer will. This is not a sustainable practice for the average person, nor should it be, but it opens a window into the plasticity of the human nervous system, how far it can bend before it breaks. The lesson is not to mimic sleep deprivation, but to understand that the limits we perceive are often constructs of untrained neural circuits. Through intentional discomfort, focus, and repetition, it is possible to shift our baseline of what's mentally and physically possible. Neurobiological override of fatigue. Goggins' ability to function without sleep illustrates how the brain can suppress natural fatigue cues through specific neurochemical systems like norepinephrine and dopamine. Extreme mental conditioning. His behavior isn't random. It reflects a trained mind capable of deliberately activating brain regions responsible for focus, alertness, and pain tolerance. Temporary enhancement of performance. Under extreme stress, the nervous system can temporarily enhance endurance, focus, and alertness, allowing performance beyond perceived limits. Cost of sleep deprivation. Despite short-term gains, sleep deprivation has serious physiological and psychological costs, including impaired memory, mood instability, and metabolic dysfunction. Neuroplasticity and willpower. Goggins exemplifies the brain's plasticity, the ability to adapt and rewire itself through discipline, exposure to discomfort, and repetitive mental training. Limits are often mental constructs. Most people operate well below their potential because their neural circuits are conditioned for comfort. Through deliberate stress exposure, those perceived limits can be shifted. David Goggins' capacity to override fatigue and function without sleep provides a striking example of how the human brain can temporarily suppress deeply rooted biological drives. At the core of this phenomenon lies the neurobiological system responsible for alertness and arousal. The brain maintains wakefulness through a complex interplay of neurochemicals, including norepinephrine, dopamine, and under extreme psychological or physical stress, these systems can become hyperactivated, allowing an individual to remain vigilant and focused even when the body signals exhaustion. This is not a simple matter of willpower. It is a precise, though often unconscious, engagement of neural circuits designed for survival. When Goggins pushes through sleep deprivation, his brain likely shifts into a high adrenaline, high cortisol state, mobilizing energy reserves, increasing heart rate, and sharpening mental focus. In acute moments, this can create a temporary state of superfunction, where attention narrows and endurance increases. These systems evolve to help humans survive dangerous or high-stakes environments, such as fleeing predators or enduring trauma. Goggins has essentially learned to tap into this survival circuitry on demand. His mind signals the body to continue functioning despite physiological debt. It's a demonstration of how environmental cues and internal narratives can override homeostatic regulation when the brain perceives a mission or purpose as vital. But this state is not infinite. It borrows energy from other essential systems, creating a deficit that the body must eventually recover from. Still, the takeaway is profound. The mind, through deep conditioning and the deliberate pursuit of discomfort, can train itself to delay or mute natural signals of fatigue. Goggins shows us that what we interpret as limits are often thresholds that can be moved, redefined, or strategically ignored, at least for a time, when the brain engages its most primitive survival tools. David Goggins' behavior reflects a level of mental conditioning that goes far beyond motivation or toughness. It's the result of a deeply trained nervous system that can regulate its own response to pain, fatigue, and discomfort. When most people feel tired, their brain interprets those signals as boundaries not to be crossed. But through repeated exposure to extreme physical and psychological stress, Goggins has trained his brain to reinterpret those signals. The prefrontal cortex, which governs decision-making, focus, and self-regulation, plays a critical role here. In moments where the average person would give in to exhaustion, Goggins engages this region to override instinctive withdrawal responses. His mental state becomes not reactive, but directed. His brain doesn't just receive signals of fatigue, it evaluates and often dismisses them. This kind of mental training isn't just motivational, it has a biological basis. Through consistent repetition of high-stress endurance tasks, neural circuits adapt. Just as muscles grow under stress, so does the brain's capacity to tolerate discomfort. The amygdala, which processes fear and distress, becomes less reactive over time. The anterior cingulate cortex, involved in emotional conflict and error detection, gets better at managing internal resistance. This doesn't mean the discomfort disappears, it means the brain becomes more skilled at moving through it without triggering shutdown. Goggins has effectively recalibrated his relationship to pain and exhaustion so that they are no longer stop signs, but markers of progress. The learned response, something that has been wired through experience, not something he was born with. His discipline, repetition, and brutal honesty with himself all contribute to the strengthening of these mental pathways. This mental conditioning shows how the nervous system, when properly trained, can shift from passive observer of discomfort to active controller of performance, fundamentally altering how the body and brain interact under stress. When the body is placed under extreme physical or psychological pressure, as in the case of David Goggins, it initiates a cascade of responses designed to enhance short-term performance, even in the absence of basic needs like sleep. This is not sustainable in the long run, but in acute situations, the nervous system is capable of entering a heightened state of function. Under stress, the brain increases the production of catecholamines, such as norepinephrine and epinephrine, which elevate heart rate, increase alertness, and improve the ability to focus. At the same time, dopamine, the neurochemical associated with drive and motivation, surges, reinforcing the behavior and giving a sense of purpose even amidst extreme fatigue. The hypothalamic pituitary adrenal HPA axis becomes highly active, releasing cortisol, which mobilizes energy stores and keeps the body on high alert. This combination produces a temporary physiological state optimized for endurance and survival. In Goggins' case, these systems are not passively responding. They're actively recruited by a mind trained to perceive stress as opportunity. While most people interpret discomfort as a cue to stop, he interprets it as a cue to engage more deeply. This creates a powerful loop where the body supports peak performance for far longer than it otherwise would. The eyes become more sensitive to movement, the muscles more efficient at contracting, and the mind more focused on the task at hand. What Goggins shows is that, through mental discipline, it's possible to voluntarily push the nervous system into these states, triggering biochemical responses usually reserved for emergencies. This acute enhancement allows him to perform in ways that defy normal expectations. It's not about ignoring the body. It's about commanding it to shift gears through sheer psychological dominance, creating temporary periods of superhuman output driven by the body's own evolved stress response machinery. Sleep deprivation carries profound costs that go far beyond simply feeling tired. While individuals like David Goggins may be able to override the need for sleep temporarily, the underlying biological systems that rely on rest begin to break down quickly. Sleep is not a passive state. It's a critical process during which the brain performs essential maintenance. During deep sleep, the glymphatic system becomes highly active, flushing out metabolic waste that accumulates during waking hours. Without this cleansing process, proteins such as beta amyloid begin to accumulate, which over time can impair cognitive function. Moreover, sleep is when memory consolidation occurs. The hippocampus, responsible for storing new information, relies on sleep to transfer short-term memories into long-term storage. In the absence of sleep, attention, learning, and emotional regulation all suffer. The frontal lobe, which controls reasoning, impulse control, and decision-making, begins to lose efficiency, making even simple tasks more difficult. Mood becomes unstable due to disruptions in serotonin and dopamine balance, and cortisol levels remain elevated, contributing to systemic inflammation and reduced immune function. From a metabolic standpoint, sleep deprivation disrupts glucose metabolism and hormonal balance, increasing the risk for insulin resistance and weight gain. Testosterone levels drop, muscle recovery slows, and growth hormone secretion is impaired. Even one night of lost sleep can shift the body into a state of physiological stress. While Goggins may temporarily override these effects, the biological consequences still accumulate in the background. His case represents an extreme deviation from what's optimal, not a sustainable model, but a stress test of the body's resilience. The ability to perform without sleep may be impressive in isolated moments, but it comes at a price, paid by virtually every system in the body. Sleep is not optional. It is foundational to health, performance, and longevity. The brain's capacity to adapt through experience, known as neuroplasticity, is central to understanding how individuals like David Goggins achieve such extreme feats of endurance and mental toughness. Neuroplasticity refers to the brain's ability to change its structure, function, and connections in response to repeated activity, challenges, or environments. What Goggins has done is engage in a process of deliberate, repeated exposure to physical and psychological stress, which has fundamentally rewired his nervous system to perceive adversity differently. Over time, stressors that would trigger withdrawal or fear in most people become familiar stimuli to him, signals not of danger, but of opportunity. This is not the result of talent or genetic advantage, but of long-term conditioning. Neural pathways involved in pain processing, emotional regulation, and self-control, such as those in the prefrontal cortex, insula, and anterior cingulate cortex, become more efficient with repeated activation. As he repeatedly puts himself in difficult situations, these regions strengthen, allowing for quicker recovery from discomfort, better focus under pressure, and reduced emotional reactivity. The more he voluntarily seeks hardship, the more these circuits adapt, creating a brain that not only tolerates stress, but is shaped by it. This doesn't eliminate pain or fear, but changes his relationship to them. Where others might interpret pain as a stop signal, his brain processes it as a familiar part of growth. This kind of adaptation requires intention. The brain does not change randomly. it changes in response to what it encounters regularly. Goggins has made suffering and effort a constant, and his brain has responded accordingly. His experience is an extreme example of the nervous system's flexibility. Through repeated exposure to adversity and conscious engagement with it, the brain develops new baselines for effort, discomfort, and persistence. It becomes not only possible, but normal to push well beyond previously perceived limits. What most people consider their limits are often not determined by the body's actual capacity, but by the mind's interpretation of discomfort. The nervous system is designed to keep us safe, and as such, it tends to err on the side of caution. When the brain perceives signals of pain, fatigue, or stress, it interprets them as threats and sends strong urges to stop or retreat. However, these signals are not always reflective of true physical failure. Rather, they are thresholds set by untrained neural circuits meant to preserve energy and avoid risk. David Goggins challenges this by consistently overriding those early demnum signals, exposing the nervous system to repeated stress and discomfort until its thresholds begin to shift. This process begins with reframing, recognizing that feelings of fatigue or struggle are not signs of weakness, but signs of adaptation. With enough repetition, the brain learns that these signals do not mean stop, they mean keep going. Neural circuits involved in interoception, the brain's awareness of internal bodily states, become recalibrated. The anterior insula, a region tied to processing pain and internal effort, adjusts its baseline, making what was once overwhelming feel manageable. At the same time, the prefrontal cortex strengthens its top-down control over instinctive reactions, allowing conscious focus and determination to override automatic resistance. Through this practice, the gap between perceived limits and actual capacity narrows. The brain becomes less reactive to signals of discomfort and more willing to explore what lies beyond them. This kind of adaptation doesn't happen overnight. It's the product of thousands of intentional decisions to stay engaged when the mind wants to quit. Goggins has built a system where his perception of limits has been shifted, not because his body is superhuman, but because his brain no longer treats discomfort as a reason to stop. David Goggins stands as a living example of what becomes possible when the human mind is deliberately trained to override comfort, resist fatigue, and reframe pain as a tool for growth. His ability to push beyond sleep, ignore exhaustion, and embrace suffering is not the result of superhuman genetics, but of a nervous system reshaped by relentless exposure to adversity and intentional mental conditioning. He doesn't defy biology. He manipulates it through discipline, repetition, and purpose. The systems that govern our limits, pain, perception, fatigue, emotional resistance, are not fixed walls, but flexible boundaries. Goggins proves that with focused effort, those boundaries can be stretched far beyond what we believe is possible. His story is not a prescription to live without sleep or push recklessly, but a challenge to question the limits we've accepted and to understand that the brain, when trained, can become a far more powerful tool for endurance, resilience, and transformation than we often realize.